Hi students, today we are going to see class 10 maths chapter 1 real numbers exercise 1.1 express each number as a product of their prime factors. So here we are going to do the prime factorization for 140. So that will be divided by 2 it is 70, and for 70 divided by 2 it is 35, 35 divided by 5 it is 7, 7 divided by 7 it is 1. So here these are the factors. So 2 into 2 into 5 into 7, so that is 2 squared into 5 into 7. Next for 156 prime factorization, 156 divided by 2 is 78, 78 divided by 2 it is 39, 39 divided by 3 it is 13, so 13 divided by 13 is 1. So 2 into 2 into 3 into 13, so this will be the prime factors. Now third sum 3, 8, 2, 5, so prime factorization divided by 3, so it will be 1275, and divided by 5 it will be 255, divided by 5 it is 51, 51 divided by 3 it is 17, so 17 divided by 17 it is 1. So here the prime factors will be 3 squared into 5 squared into 17. Next for the fourth sum 5005 divided by 5 will be 1001, 1001 divided by 7 it is 143, 143 divided by 11 it is 13, 13 divided by 13 it is 1. So the factors of 5005 will be 5 into 7 into 11 into 13. Next for the fifth sum 7429, so divided by 17 we will get the answer as 437, 437 divided by 19 it is 23, 23 divided by 23 it is 1. So the factors are 17 into 19 into 23. Second sum, find the LCM and the HCF of the following pairs of integers and verify that LCM into HCF it is the product of the two numbers. So here first we are going to find the HCF and then we are going to verify it using this formula. LCM into HCF is equal to product of the numbers. First sum 26 and 91. So for 26 the HCF will be 26 divided by 2 it is 13, 13 will divided by 13 it is 1, and for 91 it is divided by 7 it is 13, 13 divided by 13 it is 1. So here the highest common factor for 26 and 91 will be 13. So this is the common term. So the common factors will be the HCF, and LCM will be 26 into 91 divided by HCF. So 26 into 91 will be 2366 divided by 13. So answer will be 182. So this is the LCM. So here in order to verify HCF into LCM will be equal to the product of the numbers. So 182 into 13 we will get the answer as 2366, and hence it is verified. Next for the second sum 510 and 92. So 510 prime factorization divided by 2 we will get it as 255, 255 divided by 5 it is 51, 51 divided by 3 it is 17. So 17 divided by 17 it is 1. And for 92, 92 divided by 2 it is 46, 46 divided by 2 it is 23, 23 divided by 23 it is 1. So here the HCF will be 2. So this is the common factors in both of them. So here the HCF it is 2. So using this HCF we can find the LCM. So LCM will be the product of the numbers divided by HCF. So 510 into 92 divided by 2 will be 46,920 divided by 2, so that will be 23,460. In order to verify this, we are going to use LCM into HCF is equal to product of the two numbers. So 23,460 into 2 will be 46,920. So hence it is verified. Next third sum 336 and 54. So prime factorization 336 divided by 2 it is 168, 168 divided by 2 it is 84, 84 divided by 2 it is 42, 42 divided by 2 it is 21, 21 divided by 3 it is 7, 7 divided by 7 it is 1. And for 54, 54 divided by 2 it is 27, so 27 divided by 3 it is 9, 9 divided by 3 it is 3, 3 divided by 3 it is 1. So the prime factorization 336 will be 2 to the power of 4 into 3 into 7, and for 54 it is 2 into 3 to the power of 3. So here the HCF will be 2 and 3, that will be 6. So in order to find the LCM, the product of the numbers divided by HCF. So 336 into 54 divided by 6, we will get the answer as 3024. And in order to verify this, we are going to use LCM into HCF is equal to product of the two numbers. So 3024 into 6 will be 18,144, and hence it is verified. Next, third sum, find the LCM and HCF of the following integers by applying the prime factorization method. So for 12, here we know that 12 divided by 2 it is 6, 6 divided by 2 it is 3, 3 divided by 3 it is 1. And for 15 it is 15 divided by 3 it is 5, 5 divided by 5 it is 1. And for 21, 21 divided by 3 it is 7, 7 divided by 7 it is 1. So when we are going to write the factors, for 12 it is 2 squared into 3, for 15 it is 3 into 5, and for 21 3 into 7. So here the common term is 3, so the HCF will be 3. So when in order to find the LCM, we need to multiply all the factors. So LCM will be 420. Next, for the second sum, 17, 23 and 29. From these numbers we know that these are the prime numbers, so they will have only one factor. So there is no common prime factor that exists. So since HCF here it will be 1 since they are all the prime numbers. So LCM will be product of all the factors. So that will be 17 into 23 into 29, that is 11,339. Next, for the third sum, it is 8, 9 and 25. For 8 it is 8 divided by 2 it is 4, 4 divided by 2 it is 2, 2 divided by 2 it is 1. And for 9 it is divided by 3 it is 3, 3 divided by 3 it is 1. And for 25 it is 25 divided by 5 it is 5, and 5 divided by 5 it is 1. So here also when we are seeing HCF, there is no common factors. Here it is 2, here it is 3 and here it is 5. So they all have only 1 as the common factor, and for the LCM we know that they are the product of all the factors. So that will be 2 cube into 3 squared into 5 squared. So the answer will be 1800. Now fourth sum, given that HCF for 3006 and 657 will be 9, find the LCM. So they have given the HCF and we need to find the LCM. So the formula here will be HCF into LCM is equal to product of the two numbers. So here the product of the two numbers will be 3006 into 657 will be 20,000 LCM will be 2,1,042. So the product of the numbers will be 2,1,042. So using this we can find the LCM. So LCM will be the product of the number divided by the HCF. They have already given it as 9. So 2,1,042 will divided by 9 will be 22,338. So this is the LCM. Next, fifth sum, check whether 6 power n can end with the digit 0 for any natural number n. So we know the factors for n 6 as 2 and 3. So 6 to the power n will be 2 into 3 is equal n, that is 2 to the power of n and 3 to the power of n. So for any number to end with 0, it must be either be divisible by 10 or by 5, which means that it must have either 2 and 5 as the factors. But here we already know for 6 that is no factors as 5 or 2. It is having the factor as 2 and 3. So 6 power 5 does not contain 5 as a factor, and hence it cannot be n with 0 for any natural number n. Now sixth sum, explain why 7 into 11 into 13 plus 13 and 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 5 are the composite numbers. So here we can take this 13 as a common and we can write it as 7 into 11 plus 1. So 13 into 77 plus 1, so 13 into 78. So we know that 13 will be the prime number, and for 78 alone we are taking the prime factorization. So 78 divided by 2 will be 39, 39 divided by 3 it is 13, 13 divided by 13 it is 1. So here the factors will be this 13 into 2 into 3 into 13. So we can write it as 13 squared into 2 into 3. So since this term has multiple factors, it is a composite number. Second, for this also we need to for this number also we need to prove them it as a composite number. So here also we are taking 5 as a common and writing 7 into 6 into 4 into 3 into 2 into 1 plus 1. So that will be 5 into 1008 plus 1, that will be 1009. So 1009 cannot be factorized further. So therefore that is we are having more than 2 factors. The factors here are 5, 1009 and 1. So hence it is a composite number. Now seventh sum, that is a circular path around a sports field. Sonia takes 18 minutes to drive one round of the field while Ravi takes 12 minutes for the same. Suppose they both start at the same point and the same time and go in the same direction. After how many minutes will they meet again at the starting point? So here they have given we need to determine the Sonia and Ravi when they will meet again. So we need to find the LCM. So Sonia is taking 18 minutes and Ravi is taking 12. So first we are prime factorization. So 18 divided by 2 it will be 9, 9 divided by 3 it is 3, and 3 divided by 3 it is 1, and for 12, 12 divided by 2 it is 6, 6 divided by 3 it is 2, 2 divided by 2 it is 1. So here we know that for both the factors, for 18 it is 2 into 3 squared, and for 12 it is 2 squared into 3. So in order to find the LCM we need to multiply all these factors. So answer will be 36. So Sonia and Ravi will meet again at the starting point after 36 minutes. Now we are moving into second exercise, exercise 1.2. First sum, prove that root 5 as irrational number. So irrational number means they will be having the rational numbers will be having the pattern as p by q, and irrational numbers we know that they are the never ending numbers. So here in order to prove root 5 as irrational number, we are going to take root 5 as a rational number, that is we are going to assume. So we can express root 5 as equal to p by q. So p by q it is a rational number. So here p and q are the integers, and q should not be equal to 0 with no common factors. So both of them will be having not a common factors, meaning that they are co-prime. So first we are going to square on both the sides. So root 5 whole square is equal to p square divided by q square. Okay, so here on squaring root 5 we will get the answer as 5, and here it will be p square by q square. So we are going to multiply by q square on both the side in order to remove this denominator. So that will become 5q square is equal to p square. Here q square is divisible by 5. So q is also divisible by 5, meaning that since both p and q are divisible by 5, they will be having a common factor. But what we have assumed that they are not having any common factors. So here they are having the common factor as 5. So this contradicts our assumption that they are co-prime. So hence our assumption root 5 rational number is wrong. So root 5 is a irrational number. Now second sum, prove that 3 plus 2 root 5 as a irrational number. So in order to prove that irrational number, we are going to assume 3 plus 2 root 5 as a rational number, and we are going to express that as p by q. So 3 plus 2 root 5 is equal to p by q, and here we are going to bring this 3 to the other side. So that will be 2 root 5 is equal to p by q minus 3, and we are also going to bring this 2 here. So it will be root 5 is equal to 1 by 2 into p by q minus 3. So since p and q are the integers, since this p by q we know that it is a integers, they will be also a rational number. So if this is a rational number, then this is also a rational number, but this contradicts our assumption, right? So hence 3 plus 2 that 5 rational number is a false statement, so it will be a irrational number. Next, third sum, prove that the following are irrational. 1 by root 2. Here also we are going to assume this 1 by root 2 as a rational number and express it as p by q. So 1 by root 2 is equal to p by q. So here we are going to reciprocate this. So that will become root 2 is equal to q by p. So since q by p is a rational number, and as p and q are the integers, then root 2 also will be a rational number, which contradicts the fact that root 2 is irrational. So our assumption is false. So 1 by root 2 is a irrational number. Next sum, 7 root 5. Let us take 7 root 5 as a rational number and express it as p by q. So 7 root 5 is equal to p by q. So root 5 is equal to p by 7q. Since p by 7q is a rational number, so root 5 also will be a rational number. So this contradicts the fact that root 5 is irrational number. So our assumption 7 root 5 rational number is wrong. So 7 root 5 is a irrational number. Next, third sum, 6 plus root 2. Here also we are going to express 6 plus root 2 as a rational number. So 6 plus root 2 is equal to p by q. So root 2 is equal to p by q minus 6. So since p and q are the integers, p by q minus 6 is a rational number. So root 2 also will be a rational number, but this contradicts the fact that root 2 is a irrational number. So our assumption is false. So 6 plus root 2 is a irrational number. So in the next video we can see about the chapter 2 polynomials. If you like this video, please do share with your friends, and you can download all these handwritten notes from my website www.moscowcbse.in. Thank you.